On problem 55 from the physics homework. A 200 kg weather rocket is loaded with 100 kgs of fuel and fired straight up. It accelerated upward at 30 meters per second squared for 30 seconds, then runs out of fuel. A. What is the rocket's maximum altitude? And B. How long before the rocket hits the ground? Before I begin solving this problem, I'm going to go through the known, unknown, important information, as well as the figure on the right. The known information is the rocket's initial acceleration and how long it is accelerating for. The unknown is the maximum height and the total time that the rocket spends in the air. These are the two things that we will be solving for. The important information are these functions that I've written out here, this one being the position function, that will be especially helpful when solving this problem. This figure illustrates the rocket's travels from its initial position to its final position. At its initial position 1, the rocket is on the ground. Position 2, it has been fired and is accelerating at a constant rate, the rate given in the problem. At position 3, the rocket's run out of fuel, starts decelerating, but continues traveling upward until it reaches position 4, the maximum height at which the rocket's velocity will be 0, after which the rocket will begin to fall at a constant rate, the rate of gravity, until it finally reaches its final position on the ground. To begin, we need to solve for the height of the rocket, or the rocket's final position after it's run out of fuel. So we plug in the known information from the problem, and we find that the rocket travels 13,500 meters with fuel, or while it is accelerating. When we multiply the acceleration and the time in this function, we get the rocket's velocity. We then need to solve for the new amount of time the rocket spent decelerating while still traveling upwards. Using this function here, we can plug in our known velocity that we solved for, the 900 meters per second, the final velocity minus the initial velocity being 0, divided by the acceleration, and we get 91.8 seconds. This will be the time that the rockets continued traveling after it ran out of fuel. Now that we have the time, the velocity, and the initial positions, we can solve for the actual maximum altitude. This maximum altitude being 54,826 meters. For part B, we will continue to use the final position function. Part B asks how long before the rocket hits the ground. We have already solved the amount of time the rocket spends from position 3 to 4, and we are given the rocket's time at positions 1 and 2 being the 30 seconds it spends accelerating, and times 3 and 4 being this 91.8 seconds we already determined down here. So now we just need to solve for the time the rocket spends falling in part B. To do this, we will plug in the known information, the initial position, which is its maximum altitude, followed by the velocity, which was 0, because the rocket has yet to fall, as well as the following acceleration. We then solve for dt, which we find here to be 105.8 seconds. We then take that value, add 30 plus the 91.8 seconds from before to get a total time of 227.6 seconds, or 230 seconds, rounded for significant figures. And that is how long before the rocket spends hitting the ground.